Hey there, let's talk about using Makefiles and the make build system. So what's a build system? It's basically just a program that helps you compile your program. In a previous video, I talked about the idea that it's really cumbersome to type out build commands, compiling commands, linking commands, and so forth for your programs directly into the command line. So slow and cumbersome, and you'll forget everything that you're supposed to be doing. So the next upgrade from that was, in a previous video, I talked about let's take all the commands and put them into a script so that we don't really have to remember all the commands. We can just, create a build script and then just kind of run it when we want our program to compile and link and execute. But then the thing is about a script is if you have a very, very large program, it might take a very long time to compile. So a build system will take care of that for you. The build system that I'm about to show you, the make build system, it can carefully calculate which source code files you've actually changed since the last time that you built your program, and it will only rebuild the source code files that actually need to be rebuilt, into their corresponding object files and such. So as a personal example, a long time ago, before I learned how to use build systems, I had a giant program that I wrote myself. It took like an hour to compile, and every single little change that I made, I would just have to wait for like an hour. Like I'd have to go get a sandwich or go do something else or work on a different project for an hour, then come back and see if my changes actually affected anything. Somewhat quickly, I got irritated enough that I looked into build systems, and I realized that Make, the one that I'm showing you today, is pretty easy. It goes really, really far, but it's pretty easy to get started. And it drastically reduced my compile times. After I set up the Makefile and everything so that I let the build system do the building, my build only took like a minute. So I could do like a quick change and then just wait 1 minute to see the results and then another quick change and so forth. Okay, so if you look at the screen here, I'm sitting here on a blank desktop. Hopefully I'm recording everything. Am I? I'm sitting on a blank page here. So let me just make a couple of source code files. This is not a tutorial for C++ or assembly or anything. I'm just gonna copy paste a couple of sample programs in here real fast. So I'm creating a C++ source code file. I'm calling it first.cpp, and it's going to call functions from other source code files. This is going to be a hybrid program. Again, don't really worry about this. My other videos already explained hybrid programs and so forth. I'm just going to show you how to use the make build system. So let's make another source code file called second.c, and then another one called third.asm. So I'm linking three source. Whoops, that was wrong. I'm linking three source code files, and they're all in different languages, just to prove to you that this will work with a hybrid program. And so you can kind of see I've got first, second, and third. The first one is C++. The second one is just C. The third one is assembly. If I look at it real fast, get ready to pause the video, then you can see that it's C++. And if we look at the second one, it's just C. And if we look at the third one, it's just a very simple assembly program, and they just sort of say hello, and that's it. Okay, so at this point in my other video, I would have made a compile script. I'd say nano compile, and then I'd stick a bunch of compile commands inside of it. Let's see, do I even have that from last time? Let me see if I got it. If I have it, I'll just paste it real fast. Just to show you, compile, I don't think I've got it. Oh, I do! Okay, I'm just gonna paste it in here, and it's not the point of this video. Check my other video if you wanna kind of understand everything that's going on in here, but it's just a script. So I'm gonna go compile, clear, and then list. And then in the last video, I just said, let's execute the compile script. And it compiles everything, and it links the binary. And then I can run main, which is my binary, and then it just runs this program. So it's no problem. It seems okay, but again, imagine that your program is huge, many lines of source code in every single file, and many source code files. And perhaps you're pulling in libraries and shared objects and just like, a bunch of other stuff. Your building could slow down drastically. So I'm going to remove the compiler script, and then I'm going to manually remove all the compiled object files. I got to be careful with this. Remove the binary. Okay. So now I've got that 1, 2, 3. Okay. Now I'm ready to set up a Makefile. So I guess first you probably should have the make build system installed. If you're learning about C++ and assembly, you probably already do, but just so you know, it's going to show up in Ubuntu as the build essentials package. So sudo apt install build essentials. I can't remember if this is plural or not. It's either build essentials or build essential. You can do an apt search or a DNF search depending on your system. We can do build essential, see what shows up. So I'm just going to go to the top, build essential. Okay, so it was singular, not plural. I have it installed already. Let's see. If you just want to install make by itself, you can probably do apt search just make and go up to the M's. You can see right here, it's just sudo apt install make is all you really have to do to get the whole make build system. They've got a website, search for GNU make. I'm going to type it on the screen here, GNU make, search for that. You'll get a nice website with a bunch of documentation and examples that go way beyond this video, but I'm just going to show you the basics so you can get started. So the first thing you should do is create a file called Makefile. I think under lowercase m is supported, but I usually do uppercase M, which is obviously supported because I always do it. And what you're really going to do is you're just going to create an empty file, call it Makefile, and then inside of the Makefile, you're just going to give make a bunch of commands and things that you want it to do. And then later, when you're actually ready to compile, you'll just type make as a command and then give make an instruction. And you'll have lots of instructions and targets available inside of the Makefile for make to grab onto. Okay, so moving on. The first thing I want to show you is how to define a function in make. You probably won't do this a lot, but for me, I kind of like to print pretty messages and sort of like do repetitive tasks in a function. So when you want to define a function, you just use the keyword define, and then you name the function. So I'm going to make a function called say, which I know is silly. Once you see what it's for, I know it's silly. Define say, and then I'm going to tab here, and then I'm going to tell it to print some information. I'll just put test info for now. The thing about calling functions is you usually put a $sign and then an open parenthesis, and then the name of the function, and then after that, arguments to the function. So here you can see, actually let me get line numbers up here on Nano. You can see on line 2, I am calling a function called info. It's a built-in system function. You don't have to define it yourself. And I'm telling it, I want you to print some info to the screen, and I want you to print test info to the screen, and that's it. So in my Makefile, I can just call that right away with call, $sign parenthesis, and then the keyword call, and then name the function that I want to call, closing parenthesis. And then if the function takes arguments, I put a comma and then just start providing the arguments. So I'll just say, hello, what's up? Actually, this shouldn't take my arguments right now. We'll upgrade it in a second. But so this is a very simple Makefile. It doesn't actually have any targets. It will just simply do things. This kind of stuff is useful. At the very top of your Makefile, later we're going to define like a bunch of variables, and sometimes it's nice to print them out. So I just want to show you how to start printing so that maybe if your Makefile isn't working, you'll realize that, that variable is wrong because you printed everything when it started up. You don't have to do it that way, I just like to. So how do you invoke the Makefile? We just literally type make. And because we named the Makefile Makefile, the make program will automatically figure out where it is and go find it and load it. But you can specify the name of a Makefile if you really want to. I think it's the -F switch. Actually, let me look it up just to be sure. I'm going to go man make and just go down a second here. Yeah. So this switch right here, -F, and then specify the file name or file path, or -- file, and then specify the name or path. That's how you could use a non-standard Makefile, but almost no one does that. Everyone just likes to name it this way and then just type make. So if I type make, notice how the first thing it does is it says test info, which is what I told it to do in that function, which I called. And then it says no targets, gotta stop, because we didn't add any targets yet. Okay. By the way, if you're starting to get really confused about what I'm even doing this for, like compiling and whatever, go see my other videos where we talk about compiling and linking and all that stuff. This is just to make things a lot more easy and powerful. So let's upgrade this say function, and I'm just going to put some brackets, and I'm going to say my super cool make, how about like builder, I guess. And then instead of test info, I'm going to put $1, which basically is going to tell this function, when I call say, then the $1 variable is going to show up as the first argument that I provided. So now when I call say, it should have hello, what's up as the first argument that goes into the function. So that means it should print my supercool builder and then the message that I had it print. I'll do it one more time. Notice how it says my supercool builder, hello, what's up. I just like to do it this way because then it's easier for me to differentiate messages that the build system is giving me from itself, from the actual Makefile, and messages that maybe the tools I'm calling on are giving, like GCC or whatever. So let's edit this a little bit more. The second thing I would like to do is, well, maybe I'll change this to just, now running or something. Now let's set up some variables. I'm going to do like a little thing here. I'm going to say variables, put a bunch of comments in Makefiles. Comments are just hashes. So, these lines right here don't really do anything, 9, 10, and 11. And I'm going to start setting up some variables for my compilers. So again, actually compiling is in a different video. We assume right now that you already know how to do it. So I'm going to say, let's do some variables for compilers. You don't have to do it this way, but the standard convention for naming a regular C compiler or GCC seems to be just CC as the variable name. So I'm saying a variable named CC is going to be equal to GCC. And then from this point forward, every time I use the variable CC in my script, in my Makefile, it's actually going to be like typing GCC. And if you don't understand why you would use variables, you probably need to learn how to code a little bit more, but basically it makes everything more powerful. Instead of typing GCC everywhere, and then maybe later if I want to change it, I have to go change it in a million places. Now I can just change it in one place, and so it's more powerful. Let's do the same thing for the C++ compiler. I'm going to say G++, same thing for my YASM assembler. I'm going to say we're using YASM. Also notice how when I assign variables, I'm not just using an equality or an assignment operator. I'm not just doing equals. That is a little bit different of a way to assign. You can do that, but if you just put an assignment operator by itself, just like the equal, then if you later change anything that it depends on the right side, like another variable, then it will update on the left side. So it's not really a permanent assignment. It's more like a dynamic assignment. So, if you want to make sure that the variable has a fixed value that doesn't change even if you start changing variables that it depends on, then use :equal. I'll just leave it at that for now. Not super important. You can also tab and, kind of line things up, and it's no problem. Oops. So I'm going to do that just to make things look nicer. So now let's set up some flags for C and C++ and YASM. So I'm going to create a variable called CC flags. Do the same thing again where I do the assignment operator. I'm just going to give it some flags. I want it to show me all warnings, and I want it to be pedantic about its warnings, and I want it to generate debug symbols. So remember, when we're using a good build system, we want to try to compile source code files into object files first, and then at a different stage link the object files together. We don't want to just compile everything in one fell swoop directly to a binary in one line, because we wouldn't really be leveraging the power of the build system. In a moment, I'm going to draw a diagram that tries to make this a little more clear. For now, I'm just typing up variables, so just bear with me when while I'm typing this. CPP flags. So for C++, I'm actually going to reuse a variable here. I'm going to reuse the CC flags because all the flags above are fine for C++ as well as C. So that means like in my C++ compilation, I want all warnings and I want it to be pedantic and I want to generate debug symbols. But in C++, we'll specify the C++ standard. So C++ 23. Notice how we're kind of already leveraging variables against other variables to save typing and make things a little bit more modular. If I decided that all my C was not going to show warnings or was going to convert all warnings into errors or use a different flag or something, all I'd have to do is change it in one spot, line 20, and line 21 would automatically get updated. Also keep in mind, because like I said before, we have this assignment operator here going on the right side. If I were to later change the value of CC flags, then it would be reflected if I didn't use the assignment operator. You know what? Let's just do it. Let's just do it real fast. I'm going to say call say. I'm going to say let's see CPP flags is, and then I'm just going to print CPP flags. You print variables kind of the same way that you call functions. You just put a $sign and then surround the variable name in a set of parentheses, and that's pretty much it. So I'm going to copy this line a couple times, and in between CPP flags, actually let's do CC flags. We'll assign CC flags to something. I'll say hello test. And right now, the way CPP flags is written, the assignment kind of sticks. It's like permanent, fixed. It doesn't dynamically depend on CC flags. So we should see two instances of the exact same message. Let me open up another window here because I want to keep that editor open. So we'll do make, and notice how when it prints the CPP flags, they're the same. It's the same both times, even though I changed CC flags in between those two messages. On the other hand, if I don't put that colon, if I just put assign, then now it is dynamic. Notice how the second message uses the modified version of CC flags. So keep that in mind. If you want a variable to be able to change anytime a variable that it depends on changes, you'll assign one way, and if you don't want it to change, you'll assign it another way. Okay, so that's enough of that. I'm going to take away that message, and I'm going to change this back to non-dynamic. Okay, then we'll do the same thing for assembly flags. This is going to be the YASM compiler. I'm going to tell it that I want ELF64. I want a 64-bit executable. I want dwarf to debug symbols. I think in YASM you have to specify the type of symbol. I can't remember if you actually need to. So you could try just -G if you want. It may or may not work. But I always just like to specify, at least for assembly. So then let's do some linker flags. Okay, so link flags. What is the linking stage? What's going to happen in a hybrid program? For me, it's just going to be the G++ GCC linker. So that means I'm going to do all the CPP flags because I want wall and pedantic and debug symbols, and I want the C++ standard set and all that stuff. Whatever you want to do is fine. And then I want to just specify, I don't think you have to do this on modern systems, but I'm going to specify I want to link a 64-bit executable. And then I have to specify no pi, which I think is kind of an Ubuntu thing. Your program probably won't run if you don't do this, so just trust me for now. Put no pi in the linking stage. And then we'll do another flag called no exec stack, which is also a somewhat new thing, which prevents which tries to prevent the program from executing code in your stack, which means you might be less hackable. I'm not sure if it's how safe it really is, but it probably improves the safety a little bit. Let's see, at the last minute. Okay, so now that I've set up the link flags, I need to add on the -C flag for the actual compiler flags because if you know this from my previous videos, if you're going to compile to an object file and not directly link everything right away, you need to add the -C flag to let the compiler know, oh, I just want to compile to an object file, and then later I'll come along and link. So I'm going to go CPP flags is equal to, and I'm going to say equal to itself, and then just add a -C at the end of it, and then we'll do CC flags, and then it's going to equal to itself with just a -C at the end of it. So at first I had CPP flags on line 21 equal to just this basic thing, and then I reused CPP flags for the link flags, which means if the link flags didn't use that colon, I would basically have ruined the link flags variable by the time I went down here and changed it. So you don't have to organize your Makefile this way. You can actually hard-code a lot more stuff into the variables. I just like to try to be more dynamic. It's more fun. So now we've set up all the basic variables for the compiler. Let's set up some variables for paths. So I'm going to set up paths here. So what do I mean by paths? This is a build system. It's got to know where things are, right? So for starters, you probably want to name your binary, the executable file. So I'm just going to make mine main. You can make anything you want, like my program or whatever. But, for mine, it's going to be main. And then I'm going to set up another variable that depends on it. So I'm going to say the actual binary path is just going to be, this main, meaning the current directory and main. Also, it seems like most Makefiles have it set up so that all of the intermediate files, like the object files and the binary, they get built in the current source directory, like the root of the repository that you're working with. But sometimes, and for me, sometimes also, I like to just make a build directory. So it's really, really easy to just kind of clean everything out. You just delete the build directory and you don't have to worry about the repository getting super cluttered with object files in the meantime. So I'm going to name a build directory here. I'm going to say build directory name is build. And then so you can imagine there's going to be a folder here now named build that shows up whenever, well, I'm going to add more targets later when I actually start building. We're still just naming things. So then I'm going to name the actual build directory as the current directory / and then build dir name. Okay. So that means the bin shouldn't just be in the current directory. It should be in the build dir and then a / and then instead of typing main, actually, I should probably reuse that variable. So let's do bin name. And again, reusing variables is really, really good because it just saves you work. I can change things in less places when I leverage variables more. If I had the word main written down all over the program, I'd have to change that in every single spot of the Makefile if I wanted to change main to something else. But in this case, I only have to change it in one spot. Okay, so now maybe it's probably a good idea at this point to start printing out what we've done. So I'm going to do a bunch of calls to print things. Print everything out, just for double checking ourselves. Okay, how can I do that? I'm going to do that with a call. Say. You could also just do info, and then something like that, like we did up above in the say function, if you want a less fancier build system, but I like doing it this way. So I'm going to say what? Let's do cc, and I'll just put maybe like a quality operator or something, and then I'll just print out what I put for cc. And I'll just start duplicating this line a few times, and I'll say, I'll just print out everything that I added as a variable. CPP, and then for ASM, I'll type ASM, and this just kind of, it just kind of helps you check errors. What if I typed something in incorrectly? It might take me a while to figure that out, but if I print it all out at the beginning of the Makefile running, then I can just visually inspect what the variables actually contain. So let's do CPP flags, and then we'll do CC flags. Okay, and then we'll do ASM flags. And then we'll do one more. It's going to be probably, link flags. There we go. So link flags. Printing out a lot of stuff here. Then I can print the directories, I guess. So maybe I'll duplicate this a few more times. I'm going to do build dir, the build directory, just so I know where it is, and I can verify that it's like a real path. Build dir, maybe I'll duplicate this one more time so that I can see the absolute path to the build directory. Just for my own information, because sometimes, if you get it wrong, this is another way to kind of see what's going on. So there's a function in make that's built in. You pretty much just say $, and the name of the function is abs path, and whatever you put inside of it, it'll try to give you the absolute path of that thing. So I'm just telling it now that I want to print the absolute path of the build directory. By the way, you probably don't want to convert all of your variables to absolute paths because Make has a huge problem with spaces in paths and file names. So keep it relative unless you're just going to print something. You'll find out the hard way. I mean, feel free to try it and prove to yourself it's not a good idea. But I found it the hard way many times because I kept forgetting. So then we'll just do the binary, I guess. Okay, yeah, we'll do one more. For the binary, it's going to go there, and maybe I'll duplicate this so that I can say what the absolute path is. Okay. Abs path. And then if I screw this up, I'll just look up the docs real fast or something. So we got a lot. I'm going to do clear and make so I can just see what it's going to print. And let me just double check here. Okay, so everything looks good there. Looks good there, looks good there. Looks pretty good. Absolute path to the builder is my stuff. All right, okay. So seems good so far. I'm just going to leave that in there because it'll be easy to double check it. And now we're going to do targets. So what is a target in the make build system? A target is just something that you might want to create or build or compile or something. Targets are not only for building executables or object files or something that you make. Targets sometimes can just be called. They're called phony targets, but you can just call a target and it will execute a bunch of commands within that target, even though it's not building something specific that is needed. So you can use Makefiles to do a lot of really, really powerful stuff. Let me show you first off. We'll do a target. I've already prepared something up here. I'm just gonna copy paste it here because it's gonna take a long time to type if I don't. So here's a target. An example of a target is, okay, I'm going to name the target menu, and I'm going to put a colon. So now later I can type make menu, and what will happen is it'll execute all those commands that are listed below. Each command listed below is really just going to be a shell command. You have to use tab to indent for the command itself. Notice how I have a bunch of echo statements, and then I'm just like printing stuff. Right, so this whole target, it doesn't actually build anything, but it will print a menu to the screen for me, which is pretty convenient. When you're not actually building something, like you're not building the executable, the target doesn't name an executable, then it's called a phony target. And you want to name it as a phony target with this line 67 down here, because if you don't, the build system might actually eventually end up getting confused between a fake target and something that might be sitting on your file system. Like if I accidentally put a file named menu on my file system at the root of my repository, then Make might get confused and think, well, I see the file, so therefore I don't need to build it, and then the menu will never show up again. So this way I'm saying this is a phony target, then Make won't look at the file system. It'll just always execute that target for me. So this is the basics of a target. You just name a target, put a colon, and then every line under that is a shell command that you want it to execute. So let me just show you that real fast. Let me save to be sure. So we're going to do clear, and actually the absolute paths are starting to bother me. Let me get rid of them right now because it's fine. I don't have this in my solution that I had before I made this video. Okay, and we can just sort of trim the fat a little bit. So I'm going to do clear and make, and notice how the menu target just ran by itself already. The convenient thing about Makefiles is the first target that shows up is going to be known as the default target, and it will just get executed automatically if you don't specify what to execute. So notice how I just typed make by itself and I didn't actually specify a target. I could specify make menu and the same exact thing happens. Notice how I said make menu. The menu shows up again. But if you don't specify anything, then it'll always execute the first found target. And just to prove that to you right here, I'll do, maybe I'll do like a different target. And I'll just call it hello, and I'll just have it echo hello. So now if we just execute make with no arguments, notice how it just prints hello. If I want the menu again, I gotta go make menu. Right, okay, so I'm gonna set the menu back to the default target. Another thing that sometimes people do is they'll just make a target called default. I guess I'll do that here. Make a target called default, and they'll say that the default target depends on whatever they want to actually run. And you don't even need to call it default. You can call it hello or anything that you want. So, I'll put le default just so you know that this is not a standard system name that's expected. So the default target, it's just the name of the target, then a colon. And instead of putting shell commands underneath, I could put dependencies on the right. So now I'm saying that the default target depends on the menu target, which means in the make build system, first what it's going to do is it's going to go check to make sure that menu is satisfied. Because menu is actually a fake, a phony target, it's always going to get executed. And then when it's finished and the default realizes, okay, all of my dependencies are satisfied now, then the default is going to execute. And it's actually going to end up doing nothing. I mean, we could put some commands under here if we want. I'll put the word nothing. And just to prove to you that menu will get executed first because it's a dependency of the default. And then finally the default will execute its commands and print the word nothing. Let's do that and then I'll erase the echo command there. So we'll do clear and make. Notice how the menu got printed first because it was a dependency of the default, and the default is the default target. And then after the dependencies were satisfied, then the default did its thing and printed nothing. But so let's get rid of that. And now it's just like when you do make with no arguments, then the menu gets printed. Okay, so what else can I talk about real fast here? Let's talk about silent commands. I'll put a little comment, menu. Let's talk about silent commands. You see all these @ symbols here? There are a bunch of symbols that you can use throughout a Makefile. I'm going to show you just this and a couple other ones, but basically this means don't print the command you're about to execute, just execute it. So let me show you an example real fast of what I'm talking about. Targets to show silent and non-silent commands, or a suppressed command, whatever you want to call it, basically not printing the command, just executing the command. So I'm going to name a target silent commands, and it's not going to depend on anything, so that's why I'm going to hit enter here, just like with menu, and unlike the default. So then I'm going to do tab to enter a command, and the echo command is going to say, hello, this is a silent command, or a suppressed command. Then I'm going to do basically the same thing again, but I'm not going to put the @ symbol in front. I'm going to say, hello, this is a non-silent command. So what we should see is that if we exit the silent commands target, we should see first this message gets printed on line 75, and then second we see the full command, including the echo statement that shows up on line 76, and then third we should just see the message, hello, this is a non-silent command. And then if it's a phony target, meaning it's not an actual file on the file system that you expect to be built, we have to do phony. And phony is actually a target. Notice how I'm saying .phony : indicating that it's a target. And we'll just say that it depends on, and we'll just name the command that is also a phony, or the target that's also a phony. You can specify all of the phony targets in one line if you really want to, but for me that kind of feels messy, and you're allowed to like add dependencies. So notice on line 70, I'm adding menu as a phony target, and then on line 77, I'm adding silent commands as a phony target. The way you do it is up to you, but I like to do it this way. So I'm going to do silent commands. So make, and then I'm going to do make silent commands. So now we're actually going to execute the silent commands target, so we wouldn't see a menu, and then we'll see an example of the silent commands. Notice how the first one that says, hello, this is a silent command, the actual echo command is nowhere to be found because that whole line was muted, and only the output of executing the command gets shown to you. But for the second one, remember we did not put the @ symbol on the second command, so the whole entire command gets printed. Echo, and then quote, this is a non-silent command, and then that command gets executed, and here's the result. It's the same string except just without the echo. So, you know, this line right here is, this is the command that we're about to execute. Whoops. This is the command we're about to execute. And then the last line is, this is the result of executing that command. Why would you want to print your commands? Kind of useful sometimes to see the compiler statements that show up. There have been a few times, or more than a few times in my life, where I was running a Makefile and just kind of watching it, and it was printing out all the commands that it was executing, and then I realized, oh my God, that's wrong, because it was printing. And I was able to fix that. So, you know, you don't have to print your commands, but you probably want to. So let's see. What else can we do? Okay, so here's another thing that I want to show you, how to ignore failures. So sometimes if you're compiling, your source code won't compile, right? So then that means the compilation command failed. Or if you want to do any command in general, and for some reason it returns false or it fails, then, you know, that's considered a failed command. The make build system will stop execution of any target as soon as it encounters a failure. It's kind of a good thing. What if you had a huge complicated target, which you can do it this way. I've done it this way before. What if you had a huge complicated target which not only builds everything, but then also tries to deploy it to your remote server? Well, if your program fails to build, you probably don't want the deployment part to execute, so you would hope that it would stop as soon as something failed to compile, right? So We should try to know the difference between failed commands stopping the make build system and failed commands being ignored by the build system and just continuing. So we can do it both ways. So I'm just going to do a little comment here, targets to show stopping or ignoring failures. And then I'm going to do ignore failures. So that's a target, no dependencies. And I'm just going to do false. False twice. In Bash, if you just, do a false, then it will be interpreted as a failure. So, if I put true here, it will be interpreted as true. And this is not necessarily a Makefile thing. This is a Bash thing, just like the command line. Let me show you real fast, just to prove it. I'm going to prove it to you. Okay, so hopefully you remember, if you can do echo $question, it'll tell you the return code of the last command that you executed. So if I type echo hello, and then as another command, I echo the return code of the previous command, now it's going to basically tell me echo, and then it's going to tell me whether or not echo succeeded. You see a 0 indicating that echo succeeded. It would be really weird if it didn't succeed, but whatever. Now I can modify this command just to type in some random stuff. Like what if I type in this? Notice how the second part, the echo return code part, echoes a 127. Anything but a 0 is considered a failure, usually. So it's telling me 127, and that's sometimes a standard code, meaning something wasn't found. I could also just do true, and that should give me a 0, because in Bash it understands Boolean, so it's like true, success. That's a return code of 0. It's weird, but that's what it is. If I execute false, then the return code should at least not be 0. It's probably going to be a 1. Yeah, there we go. So just letting you know, if we just execute the statement false by itself or true by itself, then that's telling us, that's sort of like simulating a failed compile command or something. I guess we could put commands in there if we wanted to, but I don't really want to run the compiler just for this. So then I'm going to do echo. This echo statement should be reached as previous errors, which I'm using false to represent, should be ignored. So now how do I know that we're going to ignore the errors? Because I put the little minus in front of the false. Notice how before it was either an @ symbol or nothing at the beginning of a command. Remember, the @ symbol does suppression. The minus symbol says, try to run this command, but if it fails, ignore it, continue with the recipe for that build target. Recipe meaning all of the commands that you wanted to execute. So that means the ignore failures target should actually fail twice and then make it to line 84 where it just prints that message. Then we'll mark this as a phony target. It's always good practice to try to mark your phony targets. I've not done that in the past and eventually regretted it a few times. So then I'm going to do stop on failures is another target, and we're going to do false. Whoops, no minus, because we actually want to stop on failure. False, and then we'll do another echo, and we'll say this echo statement should never be reached as previous errors. False should cause build termination. Okay, I'm kind of verbose, but I hope this explains it. We'll name this as a phony target too. Phony, you're a phony. Failures. Okay, so we can run both these. Maybe I'll put a comment here just to show you it's two separate things. I kind of like doing that. We can run ignore failures, and then we can run stop on failures separately to see what happens. So I'm going to do, let me get rid of this terminal window. Okay, so I'm going to do clear end, what was it? Ignore failures and then stop on failures. So ignore failures, notice how it prints false because I forgot to put an @ symbol in front of it. And then the make system itself says, hey, error, that command failed, error 1. Remember before we had the return code 1 when we just typed in false? So it's telling me that it received return code 1 from trying to execute false inside of Bash. So it detected that a failure occurred. So these two lines go together. Then the same thing again, because I have two false statements in there. And then the last statement says, this echo statement should be reached as previous errors should be ignored, because we use the minus symbol. I'm having a hard time selecting text here. I gotta go home and practice my text selection. Actually, wait, I am home. Am I? So notice how, the minus symbol right there says let's ignore. So now let's do stop on failures. Stop on failures. Notice how the first false showed up as an error to the make build system, and then make just said, we're done. We're not ignoring this error, we're just done. So keep that in mind. Anytime you have commands that need to stop the build, if they fail, you should not put a minus in front. But anytime you have commands where everything just needs to be executed, even if some stuff fails, you want to put a minus in front of there. We'll talk about a clean target a little bit later, which usually, just continues even if there's a failure. So we got silent commands, ignored commands, or ignored failures, and failures that we're actually going to stop. So now we're going to get into the meat and potatoes. Because right now this Makefile, it doesn't really do anything. It doesn't build anything for us. I'm just kind of showing you, how to work with the Makefile, like the very basics. Now let's actually start to build things. So the first thing I'd like to do is I'd like to make a target for the build directory. If you just kind of like look at my file system here, I don't actually have a build directory, right? So I want to make sure that a build directory exists. I could, of course, say make dir and then type build, but I want the build system to do this automatically for me, and also as a lesson for what we're doing. So, be sure the build directory exists. So I'm going to name a target. And this is not going to be a phony target. I think this is our first non-phony target, right? Yeah. Oh, I forgot to put the default as a phony. Might regret that one day. The default. Okay. So menu is phony and everything's phony. Okay. So now we have our first real build target. I'm just going to name the thing that I want to build. And I'm going to name it by typing the build directory variable. I could type, underscore build or whatever it is that I put for that variable. What did I put there again? Underscore build. Yeah, I could put that if I wanted to, but again, try not to hard code things. It's better to stick things in variables if you can. So since this is a target, I'm going to put a colon. It doesn't really depend on anything, because if we're just talking about building that folder, all we really have to do is execute a command to just make sure that the folder is created, right? So I'm going to do no dependencies, and then I'm going to maybe do a little call say function call just to announce that we're going to ensure the build directory. A lot of people don't do this, but I'm going to do it. Ensuring the build dir. And now I could put, what the build dir is, probably a pretty good idea, so that I can see what I'm trying to ensure. Let's just run that real fast. If I say, oh shoot, I guess I would have to do make and then name build. Let's see if that actually works. Yeah, okay. So I'm naming the build directory. You wouldn't normally actually name the build directory in the command line, but I'm doing it. So it says we're ensuring the build directory, and then now it says the build thing is up to date because the target finished executing, but nothing actually got created, right? So what I would like to do before we actually create it is replace this build dir variable with a special variable that GNU make gives you called $at. The $at variable, and I'm quoting it, you don't have to quote it, it always ends up being the name of the current build target. So again, it's a bad idea to hard code lots of different values, and it's way better to put things into a variable. But at the same time, if you can get away with hard coding a variable name multiple times, and you can use something more generic, well, then that can also increase the power of what you're doing, make things easier for you and easier for you to debug. Save yourself some time, right? Because coding is already hard enough. So if I do $at, it should show up as whatever the build dir contains, because that's the current target. So let's run that one more time. And we'll say clear and make build. Notice how it says ensuring the build dir, and then it quoted the current target, which is underscore build. Nice. So we got that. Now let's actually run a command to create the directory. That's just going to be, in Linux, the command mkdir to make a directory. And again, I could put build dir here, but it's probably a little bit smarter to just put the special variable that will change. Because what if later on I want to change the name of that variable? If I did, then I'd have to change it in 3 places now, but and possibly way more places later down the line. But if I use that special $at symbol, then I only have to change it in one spot. Okay, so mkdir. So that basically says it's going to look to see if that folder is created. If it's not, then it's going to create it with that command. So if I do that, notice how it executed that command and also printed the command. So it's like mkdir build. If we list the directory again, notice how there is a build directory. Okay. You go inside of there. Everything's fine. I'm going to remove it real fast. Whoops. Okay. All right. We're going to upgrade the crap out of our Makefile until it's somewhat decent. It's not going to be amazing, but it's going to be somewhat decent. Okay, so we have a target that will build the build directory. Now let's make our first real target that is, well, it's going to be a phony target, but it's going to do something for us. So run the program. We're going to make a target called run. And so if you type make run, then it will do everything that's needed to just run the program, which in my opinion would be building the program first. Your opinion may vary, but so I'm going to do it this way. I'm going to say run colon, because that's the name of the target. And I'm going to say that the run target depends on the build target. So remember, this means that before run can actually execute its steps, it will go quickly to the build target and execute all the steps in its recipe. So essentially I'm saying before we try to run, let's build. So it depends on build. By the way, build is not created yet. We're going to do that in a second. The only line in this recipe that I'm going to put is just the name of the binary, meaning after build is finished running, I can assume that the entire executable is actually built and it's ready to run. So then I'm just going to run it. So it's just like, first go build it somewhere else and then run it. And again, indirection and modular thinking is a lot more powerful than just sticking all the build commands right inside of the run target, because then I'd have to do that for the run target and duplicate all those commands for the build target. So this is way better. And then I'll name run as a phony because this is not an actual file I'm trying to build. There's no file named run. Then we'll do the build target, build, and link the object, files, and executable. Okay, and this is where it gets a little funny. So we're going to make a target called build, and what commands are we going to use to actually build everything? We shouldn't hard code them here. We should treat every source code file as one separate thing that needs to be built. Every corresponding object file that comes from a source file should be one separate thing that gets built from the source code that needs to be used to build, I guess, is what I should say. So what should the build target depend on? Like, what needs to be created or executed or whatever before we can say that build is satisfied? How about just the executable file itself? So I'm going to say the bin. So our main program, it should be totally built and finished and set up and created and everything before we can say build is satisfied. And then hilariously, once that's satisfied, then the build target is totally satisfied too, because it doesn't really do anything. It just asks, this is more of a shortcut. Okay, so now let's maybe first, before we link, let's start writing commands to actually build the source code files. So I'm going to do build the first object file. So remember, we have 3 source code files here. We've got first.cpp and second.c and third.asm. So that's just 3 source code files. They should map to 3 object files. Let me draw this for you for a second before we talk about it further, because I want to make sure that what I'm about to do is crystal clear when we're talking about like the dependency graph. Okay. So my mouse is all over the place. I gotta execute a command real fast. I have many monitors going on right now, and the pen just keeps forgetting that it's only supposed to be on this one monitor. Okay, so I got that. Okay. So the first thing that we should understand is that our ultimate goal is to build an executable called main. So I'm just going to draw that on the graph here. For you Windows people, you can imagine there's a .exe on the end of it, but in Linux and other operating systems, we don't really need that. So main, we want to build that. That's the primary thing we're trying to build. What does it depend on though? What needs to be built before we can create our executable? Well, we need to compile every piece of source code into a corresponding object file first, and then all the object files will be linked together into the executable. So maybe I'll write down first what the source code files are going to be. So I'm going to do, let's see, first Sorry about my writing. I don't have a smoother right now. First.cpp, and I got like a really small draw pad. I'm making lots of excuses, but I think probably my penmanship in real life is maybe even a little worse. I don't know. I was at a job a long time ago, and I was taking down names of customers. It was like a tech support center, and my boss, after he saw the paper that I was writing down, he just looked at me and he went, "Chicken scratches," and then he walked away. Okay, so we have first.cpp, and then we have second. This is why I like typing. Second.c. Okay, so we got that. And then we'll have third.asm. So third, maybe I should go slower. ASM. Okay, at least I'm not making misspellings. I know these are simple file names, but it could happen. So we have 3 source code files. They don't really depend on anything because they just are themselves. We don't need to build these source code files. So we're not going to draw any arrows indicating that these files depend on something else. They're kind of like the primary source. Like these are the things that would actually go into your Git repository, whereas the object files that we're going to generate and the executable that we generate, they would definitely not go into your repository, your Git repository. Okay, so what's going to happen? First.cpp is going to generate first.o. We're going to type that out in a second, but basically first.o. That's awful. That just looks disgusting. I'm going to keep it though. Okay, so in order to indicate dependency, we're going to draw an arrow from first O to first.cpp, indicating, all right, if we're trying to build first.o, then it will look at first.cpp and it'll check. Does it exist? If it doesn't, then there's an error. If it does exist, then the build system is actually going to check the modification dates of first.o and first.cpp. Assuming that a first.o already exists, it's just going to check. It's going to say, is first.cpp newer than first.o? If yes, then that means I have to recompile first.o. If no, I'm not going to recompile it and I'm going to save a bunch of time. This is kind of the heart of why, this build system is like so much faster. So same thing for second.o. Second.o, I'll just circle it here and we'll say that it depends on second.c. And then of course the third .o object file, it's going to depend on third.asm. So again, notice how they don't really depend on each other. Maybe if you have a C++ file, maybe if you have a C++ program that's really complicated, maybe one of your, maybe your first.o, it would depend on the CPP file, and it might also depend on some other header files that you have set up somewhere. So then there would be more circles and more arrows that we draw. But for now, it's just a simple program, so I'm just going to leave it this way. But just keep in mind that when we name dependencies in the Makefile, you want to name a dependency of everything that a source file depends on. So like first.o, it's definitely going to depend on first.cpp, but if you're doing any includes that are custom or from someone's library and not the C++ standard libraries, then you would want to say that first.o depends on those as well. Because if you change a header that you made elsewhere in the program, then you probably want to recompile that corresponding object file, right? So just keep that in mind. Anyway, we'll do first.o. Okay, so now the executable program main, that needs to be the result of linking together all the object files. So I can just say that it depends on all 3 object files with just this right here. And this is the basic idea of what we're about to type up in the Makefile itself. Keep in mind that the Make system will actually build this graph in memory under the hood to try and figure out which things actually need to be built or not. You could even launch Make with multiple threads. I'll probably forget to do it, but it's I think it's like -J and then the number of threads you want to launch in order to totally saturate your CPU and have as many things compiling as possibly can be compiled. Make will figure out which things don't actually depend on each other and then build them in separate threads at the same time. So your build system is just like so much faster. So let's see, we got corresponding object IO for every source file, and then we got the binary that depend on the objects. Notice how the binary doesn't actually depend on the source code file. What would happen is when we wanted to build the, let's say we wanted to just, this is the target, the binary target that is just named main. What'll happen is it'll look at its dependencies, and the way we're going to write it, it'll say, okay, it depends on the 3 object files. If they're already there and they're already satisfied, then it won't actually, if they're already there and they are all newer than their corresponding source files, then none of them will get rebuilt. If main itself sees that it is newer, like the existing on disk version of main is newer than all the object files, then that tells the build system, oh, I don't actually even need to relink the binary at all because the object files didn't change, which means the source code didn't change. And so you could actually like type make build and nothing happens because nothing needs to happen. It's going to be pretty cool. I'll show you in a moment. Okay, so for now, I'm going to try not to erase this. I'm going to do a toggle. I don't know if I remember. I think it's like control. Let me do the menu here. I don't want to screw it up. Toggle. Okay, it would have been control. Okay, so I'm going to toggle visibility. Just get that off there. Just in case I want to show it to you again later. So now let's make the first object file. So remember the first object file is first.o. So I'm saying now that I actually want to create a target that will build the object file based on the first source code file. I'm going to put a colon there to indicate that it's a target. And then remember on the right side, we can do dependencies. Well, we have to say that this depends on the first CPP file. If we didn't, then every single time we run the make system, then this object file is just going to get built over and over and over again, even if it doesn't need to. So now with a dependency there, it's going to look at first.cpp, and then it's going to look at first.o if one exists. If one doesn't exist, it'll definitely build it. But if one does exist, it'll go, is first.o newer than first.cpp? If it is, don't do anything. But if it's not, then rebuild it. Make sure it's fresh. Here's the other thing though. I kind of wanted to build everything inside of the build folder. So I'm going to add the variable build in front of it. Let me do it first without doing that so that you can kind of see what will happen. So it's going to depend on first.cpp. And then there's another thing you can do in Makefiles where you can, I forgot the proper name for this, but you can specify other types of dependencies where they only need to exist as a dependency. They don't necessarily need to be fully updated because, you know, the way files and folders work, if you start adding or removing files from a directory, then the directory thinks that it's been updated. And so that can kind of throw off the build system's thinking because your build directory will always think that it's been updated if anything happens. But we don't really care about the date of when the build directory was built. We just want to make sure that it exists, right? So we put a little OR bar, and we put those types of dependencies on the right side of the OR bar. Okay, maybe I'll leave a comment or something at a later date specifying the official name for that, but I mean, that's how it works. So that's the recipe. It's got dependencies. You know, in the past I've said when you name a dependency, it goes off and makes sure that that dependency is resolved. Well, that's true for phony targets and targets that sort of do other things. But in this case, if we're just naming a file, all it's going to do is just look at the modification date of the file. So now let's do the recipe. I'm going to do CPP, which means that's the C++ compiler. And I could write, you know, G++ and all the commands here directly if I wanted to, but it's kind of a waste of time and it's not very smart because we said before, what if you want to change the flags and you have 100 objects that you're building? You probably just want to be able to change one variable instead of 100 different things. So we'll do CPP flags, and then we'll, let's see, we'll take first.cpp as a source. You can imagine, again, this is like, you know, G++ happening inside of here, and then wall inside of here, and then at some point you specify the source. Okay, so just keep that in mind. And then after I specify the source, I want to specify the output, and the output is going to be first.o. And now let's use another trick which allows us to make slightly more powerful Makefiles. So again, you want to avoid hard coding stuff if you can. There's a special variable. Well, okay, let's go back first to the other special variable. Remember $at? That always refers to the current target, right? So first.o is the current target, so I don't even have to type first.o here. I can just do $at. There's another special variable, which just basically means the first dependency that's been named. So if I just do quotes and then I say this, it's weird, I know, $, and then angle bracket pointing to the left, or like a less than symbol, that's the same thing as just typing first.cpp. If you wanted to send a bunch more stuff, like if you wanted to send all of the names of all dependencies that you named into the command line, then you can use the caret, like $caret, that'll do all of the dependencies. But if we're just compiling one source code file, you probably want to just do one dependency. Like for example, if I had other thing.hpp as a dependency, I probably wouldn't want to put the up arrow, because then that would be telling the compiler, here, I want you to compile first.cpp and also other thing.hpp, which probably wouldn't work. It's probably not what you want. So instead, if I do this like arrow to the left, then it will only give it first.cpp rather than both dependencies. But I guess we're simple. We don't really need all that right now. So we got that finished. Let's see. We now have the binary. Okay, this is only going to run if I do make first.o. Maybe I should do that right now so that we can take more baby steps to making this more complicated. So I'll do clear and make, and then I'll do make first.o. So notice how when I typed first.o, it went right to this target, no problem. And then it started to, it looked at first.cpp just to see, what's going on there, if it needed to be built or not. And it also looked at the build directory as a dependency. And then finally it actually compiled. So what we should see right now is first.o sitting in the directory, and then also we should see the build directory again. Let's just double check that. So if I list everything, notice how the build directory exists. If I go remove and then remove the build directory and then clear it again, notice how we also have first.o, so I can say remove first.o. So if we go clear and list everything again, now I'm going to do one more time. Make first.o, and then if I do list, then the first.o got built and the build directory got built. Notice also that as soon as I ran that command, it did make dir on build, so it built the build directory, and then so that was the build dir target, and then it went over to the first.o target and it executed that command to actually compile it. All my variables expanded, so it's like g++, wall, pedantic, whatever. That special variable with the arrow pointing to the left was the first source code or source code file, and then the $@ variable expanded to the current target, which is just first.o. If we run this again, I'm not going to clear it. I'm just going to go make first.o. Notice how nothing actually happens. It's missing 2 lines. Up here we had 2 lines where we made the build directory and we also compiled the object file. But notice how here it just says the object file is up to date. It did not recompile it because it can tell that the source code was not changed. Let me go into another directory right here, and I'll just modify the source code file. I'll just add an extra line to it, and then I'll go back here. And if I compile it now, we should see that it chooses to compile it again because now the source code is newer than the object file. So if I go make first, notice how it did not build the build directory because it already existed, but it did rebuild the object file because the source code was updated. If I immediately try to build it again, it does not need to rebuild it because the source code didn't get updated since the last time I built. And so it says it's up to date. Sometimes you might see a message that says something like nothing to do, I think. So just keep that in mind. We're getting a little bit better now. But I'm also making a mistake here because we have a build directory, but there's nothing inside of it. I want to put everything inside of my build directory just to show you how annoying this could be. Notice how, we got a first.cpp and a first.o. Imagine if you had a million source code files, you'll have a million object files sitting in your repository or your directory, kind of cluttering the place up, right? I don't like it. I'm not a fan. You probably want to edit your git ignore so that you don't accidentally put object files into your repo. But for me, I think it's better to just git ignore a build directory and then just stick everything inside of the build directory. It's up to you, but this is the way I'm going to do it. So how do we get it to be inside of the build directory? First, let me remove the object file. Okay, let's see. We got that. We got the swap and the swap. Okay. I think I can get rid of that. That's responsible for the swap file. We probably want to put star.swap inside of git ignore so that the temporary files from Nano don't go into our repository. So now I'm gonna prefix this object file, and a lot of people don't do this, but I think it's pretty cool. I'm gonna do build dir / the object, and then now everything's gonna show up inside of the builder, or at least that one. So if I remove the build directory, just kind of list things again, then I can do make first.o, and then notice how it What happened? Oh, what did I do wrong? Oh, I did something wrong. Okay, hang on. Let me see if I can fix that. First.o. What in the heck did I do? First, second, and third. Okay, so I didn't break anything. First.o. Oh, because when I typed this on the command line, I was typing first.o, and well, that's not the target anymore. The real target now is _build first.o. So maybe this is a good time to stick our binary target inside of there. So we have the binary target. I kind of ignored it for a second because I wanted to show you an object file first. So now let's actually make the target. So we want to make the main file that gets executed. We have to link everything together. So, well, maybe this is a better description down here for that. And then up here, I'll say alias for just building the binary. Whoops. Binary building. There we go. Okay, so now we're actually going to do it. So we'll put bin. So now bin is its own target, meaning our main program that we want to create is it's going to happen somehow. The dependencies that it needs, though, should be all of our object files that we intend to create. So first, one of its dependencies should be inside of the builder. And I know this is annoying to type these variables all over the place, but kind of the price you pay for having everything outside of the working directory. But I guess that's why a lot of people don't do this. We say builder/first.o. So basically saying, before we can create the executable, we have to first build the first object file. And then we'll just name more dependencies. I'll say the builder. We separate dependencies using spaces. That's another reason that Make has problems with spaces if you're going to do like an absolute path or something. So then we're going to grab the second object file as a dependency, and then the third object file as a dependency. And so this means we just need to set up targets for each one of those object files. We only have first.o set up so far. We'll have to set up the second and the third one. So aside from those dependencies, we want to make sure that the builder is actually created. So we'll put builder as another non-time-stamped dependency like we did with the object file. Then the command we'll actually use is the linking command. So we'll say link flags, and remember CPP is just GCC, and then the link flags is the stuff that we set up above, which is basically going to be, wall pedantic G, and then M64 NoPy, all the stuff we don't want to type manually at the very bottom. So we're going to do that, link flags, and then we want to give it builder. And, we want to give it every single object file as an input. So we'll name, first.o, and then we'll name second.o, and, I'm getting irritated. I hope you can tell already. I don't want to type all these things. So we can use a shell trick. We can put a wildcard there. We can say, how about I just give you every file, asterisk, that ends in .o. So star.o basically means on that command line, it's going to go look into the build directory and just give it every object file that it sees. It's not a great idea if you have multiple different executables that you want to make and they've all got their own main functions and they're all in the same builder. But in our case, we only have one executable with one main function, so we can just throw all of the object files we want at it. If you had other types of object files you wanted to link into your executable, like for example, shared object files, you could basically do the same thing, but just go, builder star.so, or maybe not even in the builder. Let's say if I gave you a shared object file and I wanted you to link that into your program, you would just specify wherever it was. Maybe it's in the root something.so, maybe it's in a different folder. And maybe you want to create a variable up top to just kind of like name where the shared object files are or other libraries are. It's up to you, but I'm just letting you know this is how you would do it to get a shared object file in there as well. For this program, it's very simple. We just are going to grab the object files and that's it. So now we're just ready to specify the output file with a -o, and we'll use that same trick again, $@ so we don't have to specify the full target, which is just going to be the bin variable. So let's see, what do I got to do now? We got that working. If we run it right now, it should fail because it'll complain that we don't have second and third built. But at least I have enough now to use the make run target. So we can stop specifying the names of files and just say something like make run or make build, and it's just way easier to type. So I'm going to type make run. It's going to depend on build. Build is going to execute before run even tries to run. Build is going to say, well, I depend on the binary, the executable. Then that means the binary's target is going to run. It's going to depend on all these object files. So before it even tries to do anything, it's going to go down here to the first.o object file. It's actually going to build it. Then it's going to come back and try to handle the next dependency, which is second.o, but there's no target for second.o, and it's not on disk. So it's just going to fail at that point. So let's see if I'm right. We're going to do make run. Clear and whoops, make run. Okay, so ensuring the build directory. Oh, I forgot to mention that. Yeah, it's going to ensure the build directory. Then it actually builds the first object file. So far, so good. Then it complains, no rule to make the target second.o, so we can't continue. Oh, drat. By the way, just to show you, I think it's like a J. Let's say we wanted to launch this with 8 threads. I think it might be, is it lowercase or uppercase J? I can never remember. Let me try lowercase. Second, how about uppercase? Nope, okay, so it's lowercase. Well, I guess it just fails right there. I was kind of hoping it would try to spawn off 2 threads to look at second and also third at the same time and then fail twice. Maybe that's why it didn't do that, because it automatically saw right away, oh, we can't do anything, so let's just cut the whole build process. So now I'm going to just pretty much duplicate this. I'm going to do cut, 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 paste, paste, and then I'm going to say build the second object file. So we're going to depend on second. There are actually advanced patterns you can use so that you don't even have to specify the object files. You can, there's these things that people do. I did it a couple times, but I don't really like it, where you can have make sort of scan your source code directory for all CPP files and automatically compile them in the exact same way. And then the output file is like the name of the source code file and then .o concatenated at the end of it. But this video is not like that advanced, so I'm not going to do that. So we're going to compile second.c into second.o, and we need to make sure the build directory is created. And instead of using the CPP compiler, we're going to use the regular C compiler, and then we're going to do cc flags right there, and I think that's all we need. So then we're going to do the last object file. By the way, in Nano, I'm going Control K to cut and Control U to paste. And it's kind of convenient if you want to like duplicate, a few lines. We're going to use YASM to assemble the assembly code. So I'm going to do third.o, third.asm, I think is what it was. And then we have to use a totally different command now. We have to use the assembler variable. So that's the name of the tool that assembles. And then we'll give it the assembly flags. I mean, I guess it's not that different. And then we'll say, give it the first dependency, which is just the source code, and then output to the at target. So we should have like a lot of stuff ready to go. Let's see if this works now. If I say clear and make run, then what is it going to do? The first thing it does is it compiles the second object file. Notice how it did not compile the first object file, because remember, we just compiled that and we didn't change the source code. So it just ignored it, and we have a faster compile. Then it assembles, aka compiles the assembly to its own object file. And then, now that all those object files are satisfied, notice how, like, for the binary, we've got to compile all of those object files first and make sure the build directory is there. Then finally, it can execute its own recipe, which is just one command saying, let's link this stuff together by grabbing all the object files. So that's this line right here, the linking flags and the linker. So it's like GCC and all the linking flags, the NoPy and all that stuff. And it's expanded that variable. Remember, we put builder/star.o. So that glob right there basically says grab all the object files from the build directory and then output the main program in the build directory. No, I think even if you're using a build directory, sometimes people will still put their executable in the root. I don't know. It's up to you. I don't really care. Finally, after all that is done, you'll see, let's see. What we actually did is we said, let's run right? And run depends on build. So before run executes its recipe, it goes down here for build, and then build says, first we need to build that binary, and then binary's like, first we got to build the object files, and then all those get built. Finally, when the object files are built, then the binary gets to link itself. When it's done linking itself, then we go back to this point, because now finally the dependencies on line 108 are satisfied. Then that means the build target, its dependencies are satisfied. It would execute its recipe, but there's no recipe there, so it just goes back to run, because in the first place, run said, I need you to make sure that build is handled before I'll execute my recipe, or all of my statements. So finally, after all that stuff was done, then it's just a command line that just names the executable, which is going to run it. And that's this last part right here. So right there, it just names the executable using a relative path to our main executable. So now below that line, the program is actually running. It's like hello from first, hello from second, hello from third. And watch this. If I do make run again, nothing happens except executing the program. Notice how none of the object files are getting built. The binary is not getting linked. Nothing is happening because it's already done. All it does for the run target now is just run the executable. It's the same thing as if we did build main, just to run it. That's it. Of course, it's a little more proper to go /, right? You don't have to use the dot if the thing you're naming is in a different directory, but you do if it's in the same directory. Like if we just went into the build directory, by the way, here's all our build files. They're in one convenient place. You can do a git ignore on that, or you can just delete the folder if you want to clean everything. But we can't just type main here. It's not going to work. We have to do a /main because we're in the same folder. But if we're one level higher, then we could just name build main and it'll work. Okay, so let's do another thing real fast here. Let's do another target that is kind of typical. It is the clean target. This is a lot more useful when people have object files just scattered around the root of their file system there, their repository. But I like to add it in anyway for mine, even though mine's a little bit cleaner right now. So we'll do another target called clean, and we'll just say clean the build area system thing stuff. And I'm just going to put the word clean with a colon, no dependencies, meaning it'll always run right away and not depend on anything. It's obviously a phony target because I'm not going to make a file called clean, so I'm going to stick that as a dependency to phony. And then what is it going to do? Usually this is where you'd put something like, let's remove star.o, let's remove all of the object files, and then let's remove the binary file, and let's remove anything that we built so that we can just clean it. Maybe I could put that here, build dir /o. I'm going to make it a little bit better in a second. So we'll just remove any object file inside of the build dir, and then we'll also remove the binary. So when we go back into our file system, if we list the build directory, we should see that it's empty after we run this. So I'm going to do that right now. I'm going to do make clean, and then you can see that these two removal commands got executed. And then if I list the directory again, notice how it's empty. But the remove command will fail if it tries to remove something that doesn't exist. So we'll actually get like a nasty message from clean or from make if we try to clean again. So if we say make clean, it says remove, tried to remove object files, but there was nothing inside of there. No such file or directory. So then it just stops the whole process. Well, that seems okay for now, but what if you had gone in and removed or cut and pasted some object file or some executable, and that stopped other things from being cleaned? You'd probably end up being pretty frustrated, right? So for the clean target, I'm just going to say remove is a command that won't stop the build or the target. So I'm going to put a minus in front of there, meaning don't stop if something goes wrong. Just keep executing all these commands. And so now, if we do clear and make clean, notice how it actually tries to remove both types of things. It doesn't just stop on the first problem. So I guess this is the first problem. It's trying to remove the object files. Then remove says, no, I can't do that. There's nothing there. And then make says, I'm ignoring you. Stop whining. There is no bathroom. And then the same thing happens for removing the executable main. But we can make this actually a little bit more efficient. I mean, this is kind of what you'll do if everything is sitting at the root of your repo. But if we simply have a build directory and you're absolutely sure that you already have the variable, set to the correct value, then you could just remove, I don't know if I want to do it now because I'm getting scared. You could just remove the entire build directory. I'm going to do it, but I'll explain to you why I kind of don't want to do it in a second. We could remove the entire build directory. So like with the remove command, remove recursively the entire build directory, just so you don't see it if you feel like it's an eyesore. So I'm going to do make clean and do it again, do it again, do it again, do it again. And notice, well, why wasn't it? I feel like it should have failed, but I guess remove felt like it wasn't a failure if build didn't exist. But notice how the builder is gone, so I didn't really have to specify the object files. But it's a little bit safer. I don't know. It depends on your philosophy. This is way more compact and nicer. That was my first feeling, but it's also a little more dangerous because what if eventually I go up there into the variables area and I like change the builder somehow? I change its name or I change its value and I accidentally now have this variable pointed to like a dangerous path. And then if I type make clean, it just erases everything. Not sure I really like that idea, so I'm going to go back to the original way, which takes more typing. Remove every object file, and maybe before that, let's remove the binary. So if we do make build, which by the way will only build things, it won't run anything. Remember the dependency graph that we looked at a little while ago? Or not the dependency graph, we explained the dependencies. So it does everything required to build, but it doesn't actually run the program. And that's fine. I just wanted to go look inside of the build directory. And you can see it's got all the stuff there. So then if I just run make clean one more time. Oh, I have to be in the correct directory, by the way. If I try to run make clean from here, there's no Makefile in this directory, so nothing's going to happen. So I'm going to go up one level, make clean. And then if I list the build directory, there's just nothing inside of it. Okay. All right. Let me just look at my notes right here. I just finished building this whole giant Makefile. It's not even like that complicated, but I hope that you've learned a lot about making Makefiles at this point. I hope you kind of like the idea. Let me just double check there's nothing else I wanted to say for this video. La 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 la. Oh, I should point out that GNU Make is not the only build system available. It's just the one that I like the most. Remember, you can also put shortcuts in there, like any command line that you could actually type could be part of the recipe of a target. It doesn't have to only be build targets. So again, you could make commands in there that like deploy your executable somewhere or check something, or like a long time ago, I used to have a recipe. Actually, it was that program I was talking about at the beginning where I converted an hour-long compilation to just like a minute. I had another target in there called deploy. So I'd say make deploy. And what it would do is it would build. And if it built, then it would run unit tests on my code. And if those succeeded, then it would copy my source code to one of my other servers. And then remotely, it would tell that other server to build and run tests. And if all that succeeded, if it didn't succeed, then it would just quit. If all that succeeded, then it would shut down the server that I had written as a running service. And then it would copy the freshly built executable to the right location. And then it would restart the service. So basically, I just like do a bunch of coding. And then I, run my tests. If everything seems cool, then I go make deploy. And then I just wait, for like 5 minutes or whatever it took to run all the tests and do another compile and deploy everything. And my server was just totally updated just by that. So there's a lot of stuff you can do, but there are other great build systems out there. There's one called Gradle. There's one called Maven. There's other like Node.js systems. There's a ton of build systems out there. Probably a slightly more popular C++ build system is called CMake. It's more tailored to C++. But you obviously don't need to do it. It's just, I think, like a little bit easier depending on what you want to do. So keep that in mind. This is not the only system. There's a lot out there to explore, but this is definitely a great first step. Let's see, what else can I do? We showed you the diagram, showed you the info function and the targets and the dependencies and the run build. I guess I'm out of stuff to show you. That's all I had written down that I wanted to show you. Maybe I could, this is not a Git video. I'll make, I have other videos for Git, but you know, if this is a Git repository, you would nano git ignore. Just because I kept mentioning this, we'll do nano git ignore, and then I'll just say ignore the build directory and ignore swap files. So I'll say like ignore the build directory and ignore anything that's edited, and then that way when you run your git status and git add and git commit and stuff, then the build directory wouldn't even show up. So I guess it's kind of unnecessary for this project. Okay, I think that concludes this video, assuming I was actually recording this entire time. Thank you so much for watching. I hope you learned a little bit of stuff and had a little bit of fun. I'll see you in the next video. Practice, 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 and start making your own Makefile videos, and let me know. Or not your own Makefile videos. Start making your own Makefiles in your own programs, and let me know if you liked the content of this video and like if it helped you. I love receiving emails way after the fact when people say, hey, I love Makefiles now, and it's all because of you, and I do it all the time. Because then I get to sit alone in my dark room and giggle to myself. It's all because of me. Okay, I think that's probably a good note to end the video on. See you next time. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.